What's going on, everybody? Welcome back to the channel. Kind of want to get straight into what we're doing today. This is a S14 with an SR20 swap. It's built over here at Sakudo Performance. It's got forged internals, MazWorks intake, 90mm throttle body, Tomei arms, turbo, 1000cc injectors, flex fuel, all the goodies. So what we're doing today is kind of working on the tune. We have a Link ECU in the car. So what I want to do today is kind of go over the Link ECU, kind of everything about it. This isn't really going to necessarily be a tuning video, but it is going to answer some questions, hopefully for people that's looking to get a Link ECU, some of the pros with the Link, and some of the capabilities that we really like. So what we're going to do is go ahead and dive into it. I want to show you, this is the Link software. So if you're new to Link, it is the G4 system. Just because the car is so loud, I'm not going to be tuning with the car on. We need to make some adjustments to the fuel map, and so that's what we're going to be doing today. If you buy a Link ECU, a G4 Plus, if it's not a complete standalone like the Storm or the Thunder, it will come with the base map to allow you to start it. It does come with a built-in map sensor, so you're not going to be running the map sensor that comes on the car. So, that's what's going on here. So what we want to do is kind of show you, we've already done some revisions here, but when you go to open, it'll give you a list of options for the maps. We go down to the map that we've been working on. We like to save them as they go. So we have version 3 right here. So this is the G4 setup, the configuration. If you open up G4, it's going to look different because we have saved different layouts from what we're tuning. We have our configuration. This is basically a basic look at what the Link G4 looks like. You have your fuel table. We added the ignition table, your PSI. We have a boost status, ignition angle. What we like about the ignition angle is that gives you any corrections that you're going to see as far as you're running like an IAT correction. That shows you what your angle is at that moment in time on the map. So your ignition table may not line up with your ignition angle, but this is basically net adjustments. And then we have our AN, which is our analog inputs, map sensor, and then this is all of our auxiliaries, digitals, and our analog inputs, as well as status. One thing to mention, if you are running a stock ECU, more than likely you're not going to have to worry too much about the trigger scope. You still want to go by the instructions and do the trigger scope as far as the signals, but if you're running something like a Thunder or a Storm, and you're running a different cast sensor or something like that, you're going to have to basically do a trigger scope, make sure your trigger settings are right. So if you're interested in that information, we've done that on a few separate setups, so we can explain that in a different video. So message us or comment if that's something that you would like to see. Next here is, this is important to me as well, is status. If I get this to correctly, there you go, is status. So this allows you to see the status if you have any fault codes, if you have a 5-volt analog supply, battery, password protection, all that good stuff. Trigger angle for your crank, trigger angle for your cam, and then your analogs. So a really cool setup with Link that I really like is the analog input setup. So what this allows you to do is configure the car however you want to see it. If you want to run a different sensor, if you want to run 2 widebands, you can set these inputs up on the wiring in the ECU very easily. I will go through an example on that. So what you can see here is we have analog 1, 2, 3, 4, and then 5, 6, 7, 8, 9 is off. Most of these are expansions. I can't remember off the top of my head how many inputs that the G4 Plus plug and play has, but we still have a few available. We have set up the TPS, the map sensor. We're not currently using a stock narrowband. We are using the AEM, this AEM fuel gauge, but that's air fuel gauge is what that is in Lambda. And then we have our analog temp, which is our ANT1, which is our engine coolant temp. We don't have the IET welded into the intercooler piping yet, so we're not running an IET sensor. Once that's welded in, we will do some IET corrections, and then that will most likely be AN volt 2. So what I'm going to do here, I wish I had my screen record, so you're just going to have to bear with the crappy quality of the video. So when you're setting this up, like I said, this isn't really a tuning video, but it will kind of explain some of the setups here. So you're gonna have your fuel, ignition, engine protection. On your fuel setup, that's where you set up your injectors, your pulse widths, dead times, also your correction. So if you're running an ECT correction, cold start correction, all that good stuff. For ignition, same thing. Your ignition table is going to be here. Any corrections, your engine protection, which is going to be your RPMs, that good stuff, and then your auxiliaries. So you have your auxiliary outputs for your fuel, your ignition, your digital inputs, and then you will have, which is right now our start position, and then our analog inputs. So as I was mentioning before, your analog inputs is where the fun stuff really comes in. So I'm going to go ahead and show on here. I'm going to act like I'm going to add an AN volt 5. It'll pop into a window. There's a ton of layout videos on Link, so I'm not really going to get into that, but you can switch through your Link screens using the arrows here. Right now I'm using AN volt 5. Function is off, so there's nothing going to that input. This right here gives you a ton of options as to what you want to run. If you just want to run a voltage source, fuel pressure, all that good stuff, like I said, IET. So we're going to go ahead and act like we already have an IET, which would be under our temperature volt. Let's see, we'll go do fuel pressure right there. So now once you add that, it's going to give you a few different options. There's your error, so you low error is 0.5 volts, high error is 4.95 volts, and then your error value. Let's see right here. So it shows now in the analog piece that we have the AN volt 5, which is our fuel pressure, and then you can go into your cal table, so you can tell it what you want the calculation to be. So if you do have like a Nissan 350Z, you can see all these pre-selected AM. You're not going to want to use that because that's a different setup. That's for air fuel. But I'll say that I'm going to use cal table 7. Now what you can do in your settings is you go to your cal tables. So I'm going to select cal table 7, cal table, and then right here it's going to allow you to calibrate that cal table however you see fit. This is going to be the same for AFR gauges, anything that has a voltage request. And then a really cool thing with Link is you can set up these parameters however you want. So we had to do some trickiness with the TPS, so we're able to go in, do an access setup, and then you can set up your access if you wanted to see inputs for voltage, however you want to see this. It's a pretty cool setup. So that is kind of a general overview of the Link main screen for the configuration. You're going to have to really play a lot with. I mean, I'm sure anybody that knows anything about tuning, obviously your dead times and things like that. But what I would definitely recommend is getting your base map set up, getting your dead times in, do all the corrections that you know is going to help with the initial start. The last thing you want to do is obviously run it really lean, but you also don't want to run it really rich because you're going to end up fouling your plugs. You're going to end up fouling out your O2 sensor, and then you're going to think you have an issue with the cranking, but it's not going to be sparking because your spark plugs are basically fouled out. So you want to get the map as close as possible on the first startup. I know that's really hard, especially when you're starting an engine that has a break-in like these. This has aftermarket cams in it, so we're going to have to do a break-in period with the cams. So when you start the car, you want to be able to run it good enough to where you're not going to be at 3,000 RPM with 9.0 AFR or like a 0.75 lambda. So that being said, I want to kind of give you a general idea of some of the layouts that we use, and the logging is king here. That's one of the main things I like about Link. So like I said before, there's different pages here that you can use. This logging page is comes with the G4. I've created some of my own as far as boost control. So I did a time plot here where I can see engine speed, let's see, map pressure, and then wastegate duty cycle. I can set my wastegate duty cycle here based on the 4 port that I have, and then obviously engine parameters and then parameter list. I'm gonna go to logging real quick, see if I can play a log. I don't have any open log file. Let's see if I can just play one that I had. I'm just doing it with fuel trims. So as you can see here, this is your time plot. Whenever I hit play on the log, it'll start playing the time. Your parameters list is going to give you what your parameter was at that moment of the log. So you can see what your AFR is, you can see what your wastegate duty cycle is. At the time, my lambda, I was basically dialing in my lambda without fuel trim. So I was trying to see what my lambda was when I'm getting into throttle to work on my tip in. So you can see the fluctuation there, and then your parameter list will allow you to see all that. So logging feature is also a huge tool for Link. There's a ton of videos on that as well, but if that's something you would like to see, let me know. There's different boost setups as well for the Link. You can do open loop, closed loop boost setup. We haven't done anything with closed loop here. We like to dial in, or I like to dial in all the open loop stuff first, and then once you have all that, you want to get your closed loop set up. That way your long-term, short-term fuel trims aren't fighting with each other to try to get your closed loop as close as possible. So after the boost control, that's kind of towards the back. I just wanted to show you that page. Tuning, this isn't really relevant for us. It has your fuel table, and then this is kind of a cool view of some of your sensors, but that's not really useful, in my opinion, for initial setup. This is an input screen that I created that I thought was really helpful for me to make sure all my inputs were right. I set up all my inputs that I was going to be using, and then I used my cal tables so I could see what everything was before initial startup. Trigger scope, as I mentioned before, this isn't completely necessary. This grand of a setup for a plug-and-play ECU. This is more of a thunder, a storm, but I will go over it shortly. So this right here is the configuration for the Nissan. This will be pre-selected, so this is your 4-stroke. It also has somewhere around here, I'm trying to find it, your firing order. There it is. It'll have your firing order, injection mode, and then your triggers. So if you're not familiar with Link and you have, say, a 1J that's a swap, a non-VVTi, you can go to the help section of Link, and then it'll help you figure out what some of these are, and then you'll have to play with them. You can use the stock CAS wheel on this setup. It works perfectly fine. So that's that part for the S14 that we're working on. And then what do I have here? So my next big tuning page that I like to use, initial basically driving and startup, is where I'm going to be able to see my fuel table, my injection table, my ignition table, and then my settings for my runtime values, and then basically my engine coolant temp, IAT, which we don't have right now. It's just set at 68 Fahrenheit, TPS, engine speed, pressure, lambda. This is lambda versus target, so this kind of gives you a good idea when you're trying to dial in your open loop that you don't have your closed loop set up yet. And then this is my knock piece. So next screen, I'll come back to this, is I'm going to discuss knock. So I have a table I created for the knock control as well. So when you're setting up knock control, this is, in my opinion, one of the most important pieces of the puzzle. You want to be very certain that you have little to no knock especially over your target. So basically any car minus some of the old Honda B series stuff will have an internal knock sensor that's built in that you'll be able to utilize. So when you're doing your knock setup, you know, I believe it comes as off. You want to turn that to on. This is an internal knock. If you have a knock detection interface that's an aftermarket, maybe from Link, they sell one, you would use that. Right now we're using an internal knock sensor. And then you have your frequency channels, your gains. So this basically, the frequency channel and the gain channel allows you to determine what your knock threshold is. So what you want to do on your channel is figure out what your hertz is going to be for narrow or wideband. This is a calculation that you're going to do based on cylinder size. There's a mathematical equation. If I can find it, I'll put it on the screen. But for the S14, it's going to be the 6 hertz narrow band gain channel. This is basically right here, and the gain is going to be what allows you to set up your knock target versus your cylinder knock levels. So if you first start this up, you don't have your knock set up, you're not really going to be able to know what your knock activity is like. We have a time plot here that we were running to basically dial it in. So you can see here that on this setup, this is our knock. So I want to see if it has any knock here, because we were probably having some knock here because we were running it. So you can see the knock levels. It'll unzoom. So you have your knock level. Your knock global is your overall average knock. Your knock level is by cylinder, so it allows you to see maybe if you have a misfire or if one cylinder here has an issue. Knock counter is basically how many times your knock control exceeded your target. So if you have knock that is above what your target is, you're obviously going to want to counteract that with more fuel, less ignition timing. So that'll let you do that. The one reason why, I mean, global knock is a good indicator if you have knock in general. The way I like to see cylinder knock is because there is cylinder correction with Link ECU that I'll mention here. So one thing we do have by cylinder, this is 1, 2, 3, 4, as you can see our knock trim. So if your knock level, let's see if it'll zoom out. So you can see right here that I have knock. It has not exceeded the target knock, which is this map right here. So therefore, it's not saying that the knock is in excess of what that threshold is. The threshold can be anything you want it to be, so that's not a good indicator if you don't really fully understand the concept of knock control. You want to have a good basis. What they typically say is once you have knock, you don't want your target to be over 20% of what that knock is that's going to cause any detonation. What the gain's trying to do is basically filter out any knock that is a false knock, fake knock, road noise, stuff like that. So you can actually determine what that real knock's going to be. So what we like to do, or what I like to do, I keep saying we, is I go to my Power EFI tuning page. It's still right now on my data log. I go to my knock table and pull out anywhere from 5 to 10 degrees of ignition timing across the board, just to make sure that I have a conservative number. If you're running at idle, more than likely you're not going to have any knock. You're actually going to probably have a knock threshold that's going to be to where you don't run it to like 1,000 RPM. But what I do is I go in here, I pull 10 degrees of timing, and then I go back to my knock control and I see what that's doing to my number. So this knock level is what your knock's going to be going on throughout the whole table. Right here you can see that you have knock per cylinder, and it's not accessing that target, so my knock cylinder count is still at 0. So for anybody that's tuning that doesn't have a dyno, anybody who knows kind of the golden rule for timing and fuel is you basically want to dial your fuel in and then go in and do your ignition, and then based on your ignition number you'll be able to know what you're going to have to do as far as if you're going to need to add fuel, pull timing, You can jack with the ignition timing per cylinder. You can jack with fuel delivery per cylinder. So that's all good indicators that'll help you with the knock control. All right, guys. Well, that's going to be probably it for today's video. I hope you enjoyed it. This is kind of something different that we don't typically do, but I do like this portion of the car builds that we do a lot. Tuning is kind of my thing. So if you enjoy it, leave us a comment. Please let us know what else you would like to see. We do different ECUs. Obviously, we don't work with just Link. So we do have some experience in different areas and different cars. So if there's a video you'd like to see, or any questions kind of from what we did, or if you're experienced in Link or any type of VFI tuning, you also have some suggestions, then we would definitely like to hear your feedback. I appreciate all the subscribers. We are over 100 today. So I really enjoy making these videos. I hope you enjoy watching them. If there's anything else that you would like to see, like I said, please leave a comment. We appreciate it, guys. Have a good day. Peace.